Hello everyone, this is part 3 of our descriptive statistics in R series. So in this video, I'm actually going to load a data set into R, meaning I'm just going to bring in an Excel file, a CSV file into R and do the analysis in R. So the process of bringing in an external file into R is called importing a file into R. So we're going to learn how to do importing. Now, so I've already done due diligence. I've cleared up my console just to make it look neater. I've already set my working directory and cleaned up my environment. You don't have to always do it. Make sure you do it only when it is absolutely essential and you're not losing any information in the environment. For me, I want a clean environment right now. So I've done that. Now, so if we want to load in or bring in a new data set into R, from a different format other than R, we have to give R explicit instructions to do so. And those set of instructions are not generally built into the base of R, but rather these are extra instructions which are stored in what we call packages, which we can download and put into R. So the idea is I need to give R a very specific set of instructions, which imagine something like the instructions are in a book, which I have to buy from the store. And it's not enough if I just buy the book from the store, but I rather have to put it into the library, open the book and read the instructions. Only then I know what to do. So the process is very similar in R also. So if you want to buy the book of instructions, which is if you want to install a package which contains the specific instructions for R, the command for that is just install packages. And the particular name of the package we want to help R be able to read or import CSV files is called read R, R-E-A-D-R. Okay, so run this. Okay, my bad. So I made a mistake here. What I have to do is I have to put read R within double quotes. And then R will actually be able to do it. So when I put it in double quotes, let me try it now. Okay. So I've actually already installed the package read R, but it's okay. Anyway, it's still, there we go. There's some action here and R has actually downloaded this package. So you wouldn't see this initial, when you try it for the first time, you won't see this error in install packages. If you're installing the package for the first time, you wouldn't see, you will only see this part of the screen, of the console. So don't worry about it, the extra stuff here. You just have to install and look for this line where R is trying this particular URL and downloading something and telling you if the packages are installed. Now, once you do that, you have to bring it into the library. And the command to quite do that is just type library read R. And here you don't need to put them in double brackets. So now I do this. Now R knows what we need to do. Now what I'm going to do is I'm going to import the data set. And I'm going to give the data set a name. Just like how we used the name Iris in the previous video. Here we're actually, Iris was the name the data set was given in the pre-built-in stage itself. So here, because I am importing a data set, I have to give it a name and I want to call it cars93. And the name of the CSV file is actually cars93.csv. So I'm just going to stick to the same name. So to import data, I'm going to do cars93 equals read underscore CSV, that's the function. And within brackets, I put double quotes and I type the name of the file, cars93.csv. That's all. Now I can do this when I have specified my working directory and this particular file is also in the same working directory. So then I don't have to type any file path. But if this cars93 file is in a different working directory, then I have to give R a file path in order to be able to access this CSV. Now I put it in my same working directory, so I don't have to worry. So I'm just going to run this, and there it goes. So R has run this, and it has brought in something into my data environment. And cars93 has 93 observations with 27 variables. So let me understand this particular data set. So I'm going to do structure of cars 93, and it's given me a list of different variables in this data set. I have manufacturer, different manufacturers. I have the model, the type of the car, price of the car, miles per gallon, and different other features relevant to a car. So excellent. So we have now imported the data, and you see that some of the variables are actually, they have this indication called CHR, which means it's a character variable. Character is a technical term for text. Anything that is entered in text becomes a character variable. And then I have a few numerical variables and so on. Okay, so how does this data set look? So maybe I want to do head of cars 93. Let's see the first 6 rows. Now it shows me just the first 6 rows for about 1, 2, 3, 4, 5, 6, 7, 8, 9, about 10 or 11 variables, because there's not enough space to show everything. But it's pretty compact. You have all the details that have been written down for different cars. Okay, so now what I actually want to do is I want to show you a few different graphs that we can generate here. So first thing I want to do is I want to draw a histogram of this variable price. Okay, so the simplest way to do that is just to hist of cars 93 dollar price. Okay, and there we go. So we have our basic histogram, which shows the X labels, Y labels, and the title. Then I can go ahead and actually edit the X label, and I can give it a proper title and run the code. Now, instead of the x-axis just going from 10 to 60, I can make it go from 0 to 70, which is what this additional argument does, of xlim going from 0 to 70. So if I run this, I can have a different histogram. And just like how we did it in the iris data set, I can break it down into further more bins, or I can club some bins and have fewer bins and so on. So you can try the breaks argument for that. So this is a simple example of a histogram. Now suppose I want to do a bar plot of the type of car, which is this particular variable, okay? So to actually figure out what the bar plot will look like, I want to first get a sense of the frequency distribution of car type. So I want to do a table which shows a number of observations of each type. And the code to do that is, it's pretty much I'm asking R to create a table of this variable, cars 93 type. And there we go. So it's giving me a list. There are 16 compact cars, 11 large, 22 mid-size, 21 small, 14 sporty, and 9 van. So I want to draw a bar graph where the height of each bar corresponds to the frequency of each category. So the command to do that is just bar plot cars 90. And okay, so within bar plot, you actually want this table to be depicted in the bar plot. So the argument into the bar plot is actually going to be this particular table because I want to see the frequency. So this is a nested function. So this will take some time for you to get used to, but that is the beauty of R. You can just type one line of code where everything that you need can be just put one within the other, and then you can run this code. There we go. We have a nice bar chart where you have all the different categories on the x-axis and the heights correspond to their frequencies. And that is it's a pretty simple bar chart that we can immediately get. And I can add labels and titles here. So I can do xlab car type. I can see ylab is frequency. Then I can give it a title, types of cars. Okay. And it's giving me a nice X label, Y label, and types of cars. Now, what I want to do is I can go change the color of this bar and so on. I'll allow you to explore that, explore the help file for bar plot, and you can figure out how best to do it. So that will give you the help file for bar plot. Now suppose I want to do a Pareto plot where I want it going in the decreasing order of the most frequent bar first, and I mean the tallest bar first, followed by the next tallest bar, and so on. So if I want to draw a Pareto chart for the same data set, I have to go back to my table command. Okay, so I want to create a table of cars 93 type data. Now, what I actually want to do is I want to redo this table in such a way that the largest category comes first, the next largest comes in second, and so on. So I want to redo this table where all the numbers are in descending order. So what I want to do is essentially sort the table in descending order. So the command to do that is sort in R. But what I want to sort is not is this particular table. So I put that in as an input. And I want to do this in a decreasing order. So if I just do default sort, it gives me an ascending order. So the least first and the most is the last. So I can actually go ahead and create a bar plot for this type of table. So for that, what I do is I will use the same bar plot command from earlier, but instead of the first argument being just the plain table, I will want it to show me the sorted table of cars 93 type. Okay. So I've just changed the first argument. Instead of the plain table, I put the sorted table. Let's run this. We have it going from increasing to decreasing. Now, suppose I want to go it from want it the other way around. I do the same sort command. Oops. Yeah, I do the same sort command, but I add an argument saying decreasing equals true. Now let me run this. It gives me a table in the opposite order. The largest is first and the smallest is last. Now I generate my bar plot again, but I change the first argument. So for sake of ease of reading, I'm going to move all of these to the next line. The first argument is going to be sort this particular table, but I want the sorting to be in decreasing order. Okay. Now when I run this, there you go. You have it the other way around. So that's how you generate Pareto charts. And then the other one that I want to show you is how to do a pie chart. Now, pie chart is also going to be computed for a particular frequency distribution. So just like how you want different categories to be listed with their frequencies, how we wanted that information for a bar chart, we're going to need that for the pie chart also. So let me start with the table. Okay, so this is just the different types of cars. And I just want to draw a pie for all of the categories that are in this particular table. So the command to do that, to draw a pie chart, is actually just pie. So you can check out the help file for just pie. It will draw a pie chart. So how do I draw a pie chart? I want to draw a pie chart for this particular table, which is cars 93 price. And I made a mistake somewhere. Oops, sorry, I didn't want it for price. So that's an example of a very bad pie chart where it has many slices. I want a pie chart for car type. And there we go. That looks much better. Now I'll leave you to figure out the help file and see how you can put different labels here to indicate the percentage of each of these shares, whether compact is a certain percentage and so on. So that's how you create pie charts. Now, if I want to, I'll also show you how to do a scatter plot. So the command for that is just plot. The first argument will always be the value that is in your x-axis. So for that, I want to draw miles per gallon in this city. So let me look for mpg.city. That's my x variable. My y variable, I want it to be horsepower. Let me search for horsepower here. There it is. Okay. Now I'll also add a few other arguments to this. X lab is miles per gallon in the city. Y lab is horsepower. Then main title is scatter plot of MPG in the city and horsepower. For 93 cars in 19. Okay, let me just do scatter plot of MPG in city and horsepower. And I'm going to do control enter. And there it is. I have a scatter plot which appears to show a downward direction. Then if I actually I can also do a bar plot, a box plot of horsepower by number of cylinders, but that may be probably a little bit too much for our demonstration today. So I will stop this video here and I'll encourage you to play around with this R script, try out different other charts and get more comfortable.